Bismillahirrahmanirrahim. Let us go into the last part of chapter 4.6. I call it part 4, integrating product of tangent and secant. Okay, for a start, let us look at this example given in our workbook. A multiplications of the tangent and secant. Okay, the product of secant and tangent. So here, as we analyze this is like tangent power 1 odd and secant odd number as well. So when we have a secant tangent is odd, okay, tangent is odd, so consider to use the identity. What identity are we supposed to use? Okay, again, you are supposed to use the tangent square x plus 1 equivalent to secant square x. Okay, play around with this identity. Alright, so here split the factor of a secant tangent and then set the u to be secant. Let's analyze this question. So for this question, we are supposed to split the secant power 3 into secant power 2 and secant. Alright, and then to set u to be secant such that when we differentiate du dx, we get secant x tangent x. This is what we wanted. Okay, so that is the du. And hence, you can get it in terms of this and integrate and replace back. So again, when you are using or when you are having integral of the product of a tangent and secant, consider to use this identity and get the appropriate u. So here given in our workbook page 245, there are many more examples. Inshallah, let's try these questions and we can compare answer. Okay, so I intend to do it together with you people. Alright, let's do number 1 for a start. So question number 1, here we have tangent being even and secant being odd. So this is like case number 3, right? Tangent even and secant odd. So we are supposed to use this identity and reduce the integrand to the function of secant only. So let's change this tangent square. Let's change it as secant minus 1. Okay, this formula is given in our formula list for the trigonometric identity. Okay, and then we separate this. Now we have power 5. How to do the integral of power 5? And we have power 3. Okay, with respect to dx. So up to this level, we have secant power 5. There is no guideline for a single secant power odd number. So meaning, we have to use another method. Okay? We have to use another method. So what method? Let's consider to use IBP, integration by parts. Okay? So when we are using integration by parts, the formula of the question, okay, u dv will become uv minus integrate v du. And when we are to choose what is the u and the dv must be something that is easy for us to differentiate or integrate. So we know that the formula of integral of a secant square is given in our formula list. Okay, secant square is simple tangent, so that will be our dv. If our dv is secant square, meaning what will be the u? The u which is left is secant power 3. Okay, let me rewrite this. So hence, as we split this secant power 5, secant cube, and I would like to have the dv being the secant square. If we choose dv as secant square, meaning the remaining, which is the u, secant power 3. Okay, so let's differentiate du dx. Okay, here we have to look at the formula list. This is secant power 3, so we have to use the power rule. 3 secant power 2x, and differentiate further the secant into your formula list. Secant, derivative of a secant is secant x, tangent x. Okay, so that's a complete derivative of your secant power 3. We are using power rule. Alright, and then hence these questions of our integral secant power 5x dx. Okay, plugging into the formula of IBP, integration by parts. Okay, let me fill out the numbers. So as we fill out the numbers, u secant power 3, v is tangent x, minus v tangent x, and u is 3 secant square times secant is secant power 3 and tangent, so we simplify. Then we met again this term. If we notice this term, tangent square secant cube is actually the question. So later on maybe we can rearrange to get to this value, right? Okay. Next, let us look at on how to integrate the secant cube. Secant power odd numbers. There is none. So again, we have to, what method should we use? Okay, we should consider to use this tangent, right? Okay, so help me. So for this part of the question, which is quite long, and again, we cannot use this method because this is a secant power odd number and it is alone. So basically, we have done this. Refer back to your workbook, page 243. Okay, question number 3. Let's find this answer for this. So it is this question. Alright, page 243, question number 3. Let me find the answer for this question that we have done earlier. So this was the solution for our early discussion. Okay, for secant power 3. So this is the answer that we have. Let me quote the answer for our question just now. Okay, it is half of the secant theta tangent theta plus ln secant theta plus tangent theta. It's just that our variable now is in terms of x. So I'm going to quote this answer. Okay, yeah. So as for the working, it's a long working. We have to use IBP last time. So for the integral of a secant cube, okay, we quote the answer. And after this, let's fill out the numbers or the values. For the secant power 5, this is the work, and secant power 3, this is the answer. So here we still have tangent square x secant cube that we need to rearrange. Let me write it down. So as we fill out, okay, this value, and I'm filling it out, this one, okay, we're writing it back. So we rearrange. So there we have one of this question plus 3. So we have 4 of this. So hence, okay, so hence what is our tangent square? So let's divide everything with 4. So hence that would be our solution. Divide everything with 4. So there again you can see that we do need to know how to solve this, and here we are using IBP, okay, integration by parts. That is why I asked you to do this first, okay, because we still need to use it even for this topic. Okay, why so? Because here there is no guideline for secant alone power even numbers. or power odd numbers. So secant power even number, yes, we have a guideline, but here we have secant tangent and secant power odd numbers. Alright, okay.